In this step-by-step tutorial, I'll walk you through the creation of a simple Zinal program which defines the factorial function and prints out some factorial numbers to the command line. First, a quick explanation of what Zinal is and isn't. Zinal is a projectional IDE, which, unlike conventional IDEs, stores logic in a binary database rather than in text files, and portrays that logic to the user via a tree-oriented GUI rather than a character buffer. Zinal is written in, similar to, and dependent on Racket, which is a dialect of Scheme, which is a dialect of Lisp. So Zinal should seem pretty familiar to those who've used Lisp before. Zinal uses the Racket compiler and has complete access to all standard Racket libraries. However, Zinal is technically distinct from Racket, since unlike Racket, Zinal stores logic in a SQLite database rather than with character strings. Zinal does not currently support mouse input, so you'll have to use Vim-like key bindings to edit your program. As in Vim, H, J, K, and L can be used in the same way as the arrow keys. Let's get started. First, clone the repo. Second, install SQLite 3 and Racket if you don't already have them. If you're on Ubuntu, like me, make sure you download Racket from their website and not via apt-get. Zinal requires Racket version 6.8 or above, and the Ubuntu package is outdated. If you're on Windows, you may need to do some finagling with file locations after installing Racket. Now that you've installed SQLite 3 and Racket, you can invoke Zinal with a fresh Zinal database from the command line. This will initialize a new SQLite 3 database where Zinal will store the logic of your program. A Zinal database consists of one or more modules, much as a conventional program is made up of one or more files. When you create a new Zinal database, Zinal will prompt you to name the first module. Let's name it Math. Now we see a header for our inaugural module. It shows us the module's name, Math, and shows us that the module doesn't require any other modules. So let's actually write some logic. Just as a code file contains a list of expressions or statements, a Zinal module contains a list of Zinal nodes. To add the module's first node, press Shift-I, which will bring up a dialog asking which type of node to add. For now, press Enter to insert a To-Do node. The To-Do, also known as a hole, doesn't actually do anything. It is merely a placeholder representing an incomplete part of the logic. A program that contains holes won't compile. Notice that the selected element has inverted colors. The hole's natural color is orange. Let's change the hole to something useful. Press S to change the currently selected node to something else. The node type dialog appears again. This time, click the drop-down to see all possible options. First of all, there are node types for literals, booleans, characters, numbers, and strings. We have list nodes. Lists are the bread and butter of Lisp and Zinal, so we'll be using this one a lot. We have lambda node, which can be used for an anonymous function or as part of a function definition. We have define node. That allows us to define variables, constants, and functions. We have reference node, which is used to refer to any Zinal lambda parameter or Zinal definition, just as the name of an identifier is used to refer to that identifier in a conventional language. Finally, we have Racket node, which is used to refer to or invoke a function, constant, or macro from the Racket standard library. There are a number of other node types that we won't get into in this video, because they're not necessary for writing simple programs. At any rate, what we want to do is define the factorial function. Click the dialog, and then type D and enter to choose a define node. We're prompted to give the definition a name, factorial. When viewed from its parent context, a definition only appears as a short summary. In this case, we only see the definition's name, an equal sign, and ellipses. In order to view the definition's value, we press Enter. This lets us view the complete definition by itself. To return to the parent, we can press Enter again or backspace. So we see that the value of the definition is a whole. To define a function, we want to change that value to a lambda. First, we need to navigate to the value placeholder. We'll do that by pressing right, then down. Now we type S to change the node, L to select lambda, and enter. Now, factorial is a function definition, but the function has no parameters and no body. Press Shift-I and enter to add a hole to the function body. Before we come back to flesh out the function body, let's add our parameter first. Type up to navigate from the lambda body to the lambda header. Press Shift-I to add a parameter. We're prompted for the parameter's name. We can just type n and press enter. The factorial function only takes one parameter, so press down to go back to the hole that constitutes our function's body. Now we have to implement the factorial function. If n is 0, then the factorial is 1. Otherwise, the factorial is n times the factorial of n minus 1. So first we need a conditional to check if n is 0. In Lisp and in Zinal, to invoke a function, we create a list whose first element is a reference to that function. So type s, then li for list, then enter. We've changed the whole into a list. Type Shift-I to insert into our new list. Type R for racket, then press down and enter to select Racket Standard Libraries. We're prompted for the name of the racket definition that we want to use. Type if, make sure there are no extraneous spaces, and press enter. Now we have a list whose first element is the racket function if. The if function takes 3 arguments: a condition, a true expression, and a false expression. Let's create placeholders for these arguments. Type Shift-A and then enter to insert a hole at the end of the function call list. Then type O twice to insert 2 more holes. Before we flesh out the arguments of the if function call, let's first take an aside to learn more about navigation and editing in Zinal. First, we'll see how to expand and collapse lists and parent nodes. Type left 4 times, then press Shift right. You'll see that the if invocation list now becomes vertical instead of horizontal. If you type Shift left, it becomes horizontal again. When displayed horizontally, left will simply move to the previous item in the list. If you're already at the first item, pressing left again will select the parent list. If you press right while selecting the list, you'll move to the first item in that list. If you press right on a leaf node, that is, a node that isn't a list or other type of parent node, you'll move to the next item after it. Now let's see how navigation works for a vertical display. Right now works the same as before. If you use it on a list, it dives into the list, selecting the first element. If you use it on a leaf node, it moves to the next sibling. Left, however, no longer selects the previous sibling. but rather selects the whole parent list. To select the previous sibling in a vertical list, we use up. To select the next sibling in a vertical list, even if the current selection is a list, we can use down. In general, up and down will simply select whatever is in the line above or below, regardless of whether the current selection is a parent node or a leaf node. The exception is that if you're at the first node of a vertically displayed list, up will select the parent list, just as left would. Now for editing. We've seen that to change the current selection, we can type S. To insert before and after the currently selected item, press I or A. This works the same regardless whether the current selection is a parent or leaf node. To insert a hole after the current selection, we can type O. We can use Shift I or Shift A to insert at the beginning or end of a list. If the current selection is a list, the new item will be added to that list. If the current selection is a leaf node, the new item will be added to the parent list. We can type D on a hole to delete it, or D on anything else to replace it with a hole. So, pressing D twice on something that isn't a hole will completely delete it. Now that we've covered navigation and editing, let's complete our function. Let's go to the first argument and change it to a list. The first item of the list should be the racket function 0, which takes one numeric argument and returns whether or not it's 0. We'll type Shift A to insert the argument to the 0 function. We want to check whether n is equal to 0. N is a parameter of a Zinal lambda, so in order to use it, we choose the reference type. Press RE and enter. We're now prompted to choose which Zinal definition or parameter to reference. As we can see, the only visible referables are the parameter n and the factorial function definition. Type n and enter to choose the parameter. So now we have a conditional, which will check if n is 0. If it is, the true branch is evaluated and returned. Otherwise, the false branch is evaluated and returned. The true branch is pretty easy. If n is 0, we return 1. We can use the number literal node type for this. For the false branch, we want to evaluate n times factorial of n minus 1. We need to invoke racket's multiplication function, so we change the whole to a list. The first element of the list should be a racket standard library function, whose name is a single asterisk. Most languages use infix notation, that is, a times b, but Lisp and Zinal use prefix notation, that is, times ab. So the first element of the list is the multiply function, and the next two elements are the values to multiply. We type Shift A to insert a reference to n at the end of the list. Now we can press A to insert the second argument, which is a function called 2factorial. So the second argument is a list, whose first element is a reference to the factorial function definition. The argument to the factorial call is also a list, whose first element is the racket function minus, whose second element is a reference to n, and whose third element is the literal number 1. So now we've written a complete function in Zinal, and we can see how Zinal allows us to dynamically display the logic in either vertical or horizontal formats. Let's finish our program by actually using this function to do something. Type left several times until the whole function is selected. Then type enter or backspace to return to the parent module. Now we see that the summary of the factorial function has changed from mere ellipses to lambda n, indicating that the factorial is a function which takes a single argument. Let's have the program print out the first 7 factorial numbers. Racket has a function called buildList, which takes a number and a function, applies the function to all numbers from 0 up to the past number, and returns a list of the results. Create a list after the factorial definition. Make the first element the standard Racket library function buildList. Make the second element the literal number 7. And the third element be a reference to the factorial function definition. The result of any expression that is evaluated in the main module will be printed to standard output. So when we run this program, it'll output the factorials of the numbers 0 through 6. There's one more thing we need to do in order to compile our program. Currently, a Zinal program must be an executable. So in order for Zinal to know which module to enter and evaluate, we need to specify it as the main module. Type left several times until the whole module is selected. Now type right twice and type M. You'll see that the module is now designated as main. So when the compiled executable is run, this is the module which will be evaluated. Now we can compile our program. Use the mouse to choose the compile command from the compile menu. We're prompted for the executable name. We can simply call it fac. A dialog appears during compilation, allowing us to cancel if it takes too long. But for such a simple program, the compilation finishes quickly. Now we can go back to the command line and run the executable. As we can see, the factorials for the numbers 0 through 6 are printed to the terminal. Now you know the basics of how to write and run a Zinal program. Before the video ends, I want to quickly address a concern some may have after watching this video. The Zinal UI is currently in an early stage of development, so it's not as fluent or as efficient as it could be. It may seem to take longer than it should to write a very simple factorial function. It's important to note that other similar projects, other projectional IDEs, have more fluent UIs and demonstrate that an efficient UI is perfectly feasible for this type of IDE. Thanks for watching the video. To learn more about Zinal, check out the links in the description.